Okay, let's look next at the non-rigid transformations, which are generally what we call stretches and shrinks. Okay. So if we have a, once again, a direct effect on x in our function of either a multiply or a divide by c, okay, we're going to get a stretch or a shrink. Okay. So here's the key information though. If c is greater than 1, okay, we're going to get a horizontal stretch by a factor of c. And if c is less than 1, then we're going to get a horizontal shrink by a factor of c. Now, before we continue with the vertical, I want you to take a look at a picture of a situation that will show us this. So I'm going to go ahead and just use my x squared function as the example. Get lights again, please. All right. So if I have y equals x squared as such, and then I wanted to compare that to if I were to do y equals, let's say, x divided by 3 squared, and notice that's of the form x over c. Okay. And in this case, my c value is greater than 1, so I should expect a stretch. Okay. So let's find out if that happens. So notice the new graph that's drawn is wider than the previous graph, okay, which did exactly what we thought. It created a stretch. Okay. Now, if we were to look at, instead of x over 3, if we put, say, x over 1/3, remember, over 1/3 would be the same as times the reciprocal of 1/3, which is 3. So if I were to put in the parentheses 3x all squared, okay, keeping in mind in that version that c would be less than 1, which means it should create a shrink. So let's find out if it does by graphing. Okay. And of course it is a horizontal shrink. It got narrower. True? So if it gets narrower, that's going to be a horizontal shrink. Okay. Now, the other part when we do vertical is notice that it's a direct effect on the y coordinates because the x is left alone. We're multiplying c by whatever the y coordinates are. So we'll illustrate that by deleting these two. So if I just had x squared and I put a 3 out in front of it, okay, notice that's not a direct effect on x because what's going to happen first in the order of operations? We're going to take the x and square it, okay, and then we're going to multiply it by 3. Okay, so this is not a, we shouldn't expect here a horizontal stretch or shrink. This should be a vertical one. Now remember in our notes here it says that if it's greater than 1, we should get a stretch. Okay, so we should be looking at a vertical stretch here when we graph this. Let's find out if we do. So there's the original. Alright, and keep in mind that one thing that's kind of difficult to tell by the graph is if I just graph those two, would you be able to tell whether that was a vertical stretch or a horizontal shrink? I wouldn't be able to. Okay, so it's kind of difficult from the graph to tell which one it is, isn't it? Okay. Because really, those two things kind of make the graph look similar, don't they? Okay. So would I give you these two graphs and make you tell me which one it is without knowing the equation? No. Okay. But ultimately, like I said, a horizontal shrink and a vertical stretch essentially produce a similar looking graph. Okay. And if we do it the other way, if we were to put, instead of 3, if I put, let's say, 1/3 in front, 1/3 of x squared, okay, we should expect that be a vertical shrink, but a vertical shrink is going to look like a what? Kind of like a horizontal stretch, doesn't it? Now you'll notice that they're not exactly the same. That other horizontal stretch with the same numbers was quite a bit wider, wasn't it? Okay. So, but still, they look somewhat similar. Okay, they kind of do the same thing to the graph, if you will. Okay. All right. One thing that we're asked here in this problem, as an example, they have y equals x cubed plus 3, which is our cubic function translated what? It's up 3. It's outside the x, so it's an up or down, so up 3. And we want to, first of all, find an equation here for in part A. Find an equation for the following non-rigid transformations of this. Okay. So we want to do a vertical stretch by a factor of 4. Okay, so a vertical stretch by a factor of 4, okay, means we're going to go y equals. Okay. And if we want to make a vertical stretch, let's go ahead and look at our notes here. If we want a vertical stretch, we need to have c be greater than 1, and we just need to multiply that by the function. Now, one very common mistake at this point is going to be to write 4x cubed plus 3. Okay, that is not right. Okay. Because keep in mind, in the notation that we see here, and this is what we're going to follow every time, we multiply c by the entire function. Okay. That 4 is being multiplied by the x cubed. Is it being multiplied by the entire function? No. So what do we need to have? Make sure we have parentheses. Got to have parentheses around that, otherwise we're not going to get what we expected. Okay. All right. And then in the other one, we had to do a horizontal shrink by a factor of 1/3. Okay. So if I want to produce a horizontal shrink, okay, keep in mind, right here in our notes, if we want a horizontal shrink, okay, we're going to want c to be less than 1. Okay. So whatever we put under here needs to be less than 1. And the factor of 1/3, if you will, here's what we're going to do. If we put x over 1/3 cubed plus 3, notice again I'm directly affecting x this time, because that's what I want to create as a horizontal shrink. And then if we simplify this, of course, we don't want to leave it as 1/3. We would have what we had in that previous problem. It would be 3x cubed plus 3, and that would do it, wouldn't it? Okay, and just like the parabola, having a whole number there made it shrink, didn't it? Questions so far? All right. The last thing we're going to look at here is combining transformations in a certain order. Okay. So we have the graph of x squared here undergoes the transformations in the following order. And one thing you have to be careful with here is that if they give you a specific order of more than one transformation, you have to do it in that order, because if you did this in a different order, you might get a completely different equation. Okay? So if there's an order here, you want to make sure you follow the order very carefully. So let's start with the first one. They ask us to do it in this order, a horizontal shift of 5 units to the left. So if we do that for bullet 1, if you will, we're going to have x plus 5 squared. That would create a horizontal shift left. All right, and then for bullet 2, it says we want a vertical stretch by a factor of 3. Vertical stretch by a factor of 3 is just going to be 3 times that whole function that I just wrote. We already have the parentheses in it, so we don't need to add new parentheses. Okay. All right, and then finally in the last bullet, it says a vertical translation of 4 units up. So if we want to take this graph that we now have and move it up 4, then what are we going to do with it? Just going to add 4 on the end of it. If I add a 4, that's going to make the whole thing go up, isn't it? Questions? And just to illustrate that there would be a difference if I did this in a different order. Okay, if I did bullet 2 first, okay, then my, again, my vertical stretch in this case, if I did that first, so if I did the vertical stretch first, it would be y equals 3x squared. Okay, and then if I did the horizontal shift, 5 to the left, okay, I would write x plus 5 squared, and then if I did the translation, it would be 4. So in this particular case, going 2, 1, 3, did that change anything? No. Okay, sometimes they're the same. Okay, but what if we did the vertical translation first? Maybe there's something different if we did that first. What if we went like completely backwards here? Okay, and again, it might be the same. Okay, but it might not, depending on what the transformations are and depending on what order we do it in. So let's do it this way. If we do the vertical translations first, we'd say x squared plus 4. True. If we said x squared plus 4, and then if we did the, let's just say for argument's sake, we're going to do the horizontal next. The horizontal would be x plus 5 squared plus 4. And here's where the difference would be. If I did a vertical stretch of this whole graph, that would mean 3 times, not just the x squared plus, or x plus 5 all squared, but what? That 4 would be affected too, wouldn't it? True? So in this case, that one would be completely different than the one I got in the first place. Okay. All right. So again, key issue here is make sure that we follow the order. Okay? If they give us more than one transformation to perform, okay, we follow the order that was given. Okay. Questions so far? All right, we're going to do that same thing in order here. And in this case, it says describe how to transform f of x to show the graph of negative f of x minus 2 plus 4. Okay. All right. So we don't have an equation this time. We have a picture. Okay. We can see that there's points on here that we can work with. Okay. Ultimately, if we look at the original graph, we can see that there's a horizontal shift of 2 to the right based on this part. Okay. So if we take all these points and we shift them over 2 to the right, we would have this graph. True? Okay. And if we take this graph that we're at now, okay, and we do the flip over the x-axis that this is going to create, okay, notice that they took the points, you can stay on the same page, but they took these points right here and flipped them over the x-axis. So if I did that on this graph, I would have this point would go up here. The points that are on the axes would stay the same. This would flip down to here, so we would look like that. And this one would flip to here. Okay. So the negative sign would make it flip. Okay. And then finally, the plus 4 would make the blue graph I just drew go up. It would just go up 4. So we would take all those points and move them up 4. And when we got done, like I said, this was our graph that I just drew a minute ago. We would take that, move it up 4, and the result graph would be here. Okay. All right. Now, just to re-illustrate here the order that I did that in. Okay. When we're given something like this, okay, we did horizontal first. Okay. So horizontal translation. Okay. Then we did the reflection in the y direction. And then we did the translation vertical last. Okay. So I want to stick with that same plan. We want to do anything that has to do with a direct effect on x first. Okay. And then effects on y is in the order of reflection, translation. Okay. So unless it tells you something other than that, okay, that's the order that we want to handle things in when we draw a graph, a new graph, when we're given some transformation. Alright, so that takes a little bit of practice to make sure we follow the order correctly. Okay, part of our homework we'll be doing that to make sure we can practice and get that right.